Okay. So hello, everyone. I'm Ofer. I'm a software engineer at Google, and I work on helping companies become more productive using Google's open source ecosystem. So today we're going to talk about knowledge transfer by source code. And that is about how you transfer knowledge, so things you know about the code base, about your project, to other people across your company, on your team. Now, these techniques that I'm going to show you today, they're secret techniques used inside Google. And I say secret like this because it's all open source. And it's based on Google's open source tools. And you can actually go ahead and do the same things right after you get out of the conference. Those of you with the laptops, even as we speak. So let's start. OK, but actually, before we start, I added a few slides to this deck today, because I wanted to talk a little bit about Bazel speed. So we've talked a lot about how Bazel is fast, and it can actually compile much, much faster. This is an evaluation done by Wix, where they found that Bazel decreases the build time from 45 minutes to just 5 minutes. And you know, it seems like a good thing, but you need to think about this when you think about using Bazel. Because if you think about those 45 minutes, and maybe you're used to doing things in that time, like maybe staring at the screen, and now that you're using Bazel, you don't have that time. And some of you have been telling us that staring at the compiler makes it go faster. So Bazel doesn't work that way. And so you won't be able to do that. There's no time for knitting while the compilation is going on. And if you are waiting for the build and you're used to doing some other stuff in the meanwhile, so you won't have that chance with Bazel. And if you love multitasking and doing like 5 tasks at the same time, then unfortunately, it doesn't work so well, because Bazel is just too fast for that. So besides being fast and correct, what can Bazel help you do along with Google's other open source technologies? So I'm going to give several examples, but the focus is going to be about knowledge transfer, which is the problem of transferring knowledge across your organization. Now, when you think about knowledge transfer, there's 2 basic types, and it's like a scale between them. There's personalization, which is one-on-ones and chats, and it's basically a synchronous way of transferring knowledge. And there's codification, which is about code comments and wikis and docs, and that is async in its nature. Now, personalization, it doesn't scale, because you can talk to one person, you can talk to 2, 3, maybe 10 people, but many more than that, it's not going to scale well. And it requires you to be present. Now, codification, writing comments, writing wikis, that scales well to a lot of people, but it takes a lot of effort. And it's not an inherent part of the code, and that way it can become not up to date. And it's always confusing to make sure that the documentation is really connected to the code. So at Google, the way we tackle knowledge transfer is basically with 2 basic strategies. So first of all, we try to simplify where we can our systems. And we try to codify, not only using wikis and docs, also through source code. And that's going to be the main part of the talk. And I'm going to give some examples on that. So first of all, about simplification. So at Google, we have 1 style guide, 1 operating system for developers, 1 repository, 1 data format, 1 server communication protocol, and 1 build tool. I don't know if you've heard of it. It's called Bazel. OK, this is a simplification, but for the most part, it's correct. Now, when you think about focusing on codifying by source code, I'm going to talk about 3 main technologies: protocol buffers, gRPC, and Bazel. And they're basically the equivalent of JSON, HTTP, and Makefiles. Now, who here works with protocol buffers? OK, I'd say about half. Who works with gRPC? OK, maybe a third. Okay, so and who's thinking about working with Bazel, not yet working with Bazel? Okay, actually most of you are. So these technologies are very mature. They've been used inside Google for more than 10 years, and they're used on a day-to-day basis by Googlers. Now, I just want to say that there's other options that exist to do the same concepts that I'm going to talk about. I'm going to explain with these ones, but obviously there's other libraries out there, and you can do the same things or similar things with other libraries. So protocol buffers. You have a protodef file with the structure of your data, the data that's going to be passed around. And that can be passed around with various formats. You have JSON, standard, proto.txt, which is a textual format, and proto.bin, which is the binary format. It's compact, it's efficient, and also when the data gets transferred there, it gets transferred without the field names. For example, in this example, there's title with the ID 1. So in the data that gets transferred, the string title never gets transferred. It's always the IDs that get transferred. And this is an important point that I'm going to talk about later, so remember that. Now, the proto.txt format, anyone ever seen it before? OK. So I marked the annoying characters in red. OK. Annoying characters are the characters you don't want to deal with because you just want to deal with the actual data. Now, if you compare it to JSON, there's actually many, many more annoying characters, and there's more types of them. For example, there's commas, and there's parentheses, which you don't have. There's two types of parentheses instead of just one. So it's just built to kind of confuse you just enough to not be able to parse it later. So that's proto.txt. And also, protocol buffer generates code for you. So you get, for every language that is supported, and there's many languages that are supported, you get code generation. For example, with Java, you get these objects for free, which have getters, setters, and a lot of functions, related functions that come with them. Now, you can think of protocol buffers as a strongly typed JSON. So when the message changes, the code that's using the message, it's reading the message, won't compile anymore. And in a monorepo, you can actually change the front end. You can have a setup where the front end and the back end both use the same protocol buffer. And once you change that, the other side stops compiling, and you have to update it too, so you never forget and you never break the other side. So now we're going to go to the fun part of the talk. There's going to be a lot of examples of day-to-day scenarios which you may have encountered as part of your work. And it's kind of like Seinfeld, but for developers. So think of this scenario. There's Newman. He's a new guy on the team. And he's working with the book class. And the book class has two fields that he's worried about. There's title, and there's actual title. And he recently moved from the show business to being a developer. And now he has to work on this new task. And he can't figure out like what's the deal with this title and actual title. So he asks Debbie, and Debbie's a senior developer on the team. And what she says is that everybody gets confused. So initially we had title, and then it was just for display purposes, and it was truncated. And then we needed to add another field, which is the real title. But we couldn't change the name of the old title because we already have released apps that people have, and they need to continue working. So we just made another name, and that's how we named it, because title was already taken. So Newman sends back this emoji. It's not a smiling emoji because it's a little bit confusing. So with protocol buffers, you can actually rename stuff. You want to add a new field, so you can add this. You can add a field by. You can rename the existing field and add a new field with the old name, and that still works. That's a green check there. And the reason it works is that the data being transferred in binary format never includes the title string. It always includes just the ID 1. And that's going to continue on transferring, even if you change that name. Now, for free, you also get enums across all the languages. So you don't have to communicate changes and transfer this knowledge from the back end to the front end between teams about enum changes. So you get these for free. Now, let's look at Fred. Fred is working on a new field called ISSN. He's not sure what ISSN is. Anybody know what ISSN is? OK, I checked when I made the slides, but I kind of forgot since then. It's something like international number for something with books. I don't know. Fred doesn't know either. Fred is going to ask Becky, what is ISSN? And Becky happens to be in a meeting. Maybe she's on vacation. Maybe she's in the Bahamas and on extended vacation. And now Fred can't actually continue because he doesn't know what ISSN is. Now, he can dive to the server code, but he's a front-end developer. And maybe it's in another repo, and he's not sure which branch it is. And he kind of finds the code, and maybe it's documented. Maybe it's not really very documented very well. So with protocol buffers, there's just one file, and everybody's looking at the same file. And there's a good place to put this documentation. Now, the next scenario is about gRPC. So gRPC is like a communication protocol between servers, kind of like HTTP, but based on protocol buffers. So Becky has this new endpoint for this new feature. It's called cool server pizza order. And Fred now needs to work on it. And for Fred to work on it, he needs a lot of stuff. He needs a running dev server, so he can check what this endpoint looks like. And this running dev server, maybe Becky forgot to bring it up. Maybe she went on vacation. Maybe she brought it up, but there was an electricity shortage, and now it's down again. Maybe it's up, but he's not sure it's the correct version that he's looking at with the code. And maybe he doesn't know what the endpoint is, what the address is. But let's assume he has all that. So all this is like knowledge transfer. He's needing Becky's help to do his job. But let's assume he has his server up and running. So he still needs to kind of query the server to see what the response looks like. And it's returning this JSON, and he needs to kind of figure out and kind of reverse engineer. And things that Becky already knows, knowledge that she already has, is not properly encoded in the code base. So he needs the server up and kind of to query it. And he can actually make some mistakes because he's querying with certain requests. But maybe there's other requests that will bring more fields in. And he's not taking that into account when he's doing his front-end work. So with gRPC, what you can get is basically a definition of what the server endpoint looks like and what its requests and response look like. And this is built on protocol buffers, and it's part of the gRPC. It's part of the definition file. And you also get a client code generated for free and server code generated for free. So that's really convenient, and it takes care of a lot of stuff for you. Now let's talk about Bazel. So Bazel, basically it democratizes builds across the company. So now everyone can build everything and see everything buildable. In this example, Jared is working on this tool, and he's kind of stuck. He's a junior developer on the team, and he's kind of stuck. He's getting this weird compilation error, and he's not sure what to do. And he's asking Jevi. Jevi's an experienced developer. She's a couple of years on the team. And she actually can't reproduce the issue because it's not based on Bazel. And she has a different environment. And so she can't help him, and she can't transfer her knowledge to him in an effective way. So with Bazel, you have this reproducibility, and it makes helping other people in your company easier. Now Jared actually successfully built his tool. And now he's built this tool, and he's telling everyone, listen, this great tool. At Google, we have this great tooling culture where people can build tools and share them with the company. And it's really easy. And the reason that it's easy is because we are using Bazel. And so in this example, Jared has made this tool, and he just shares it with Patty, and Patty's a Python developer, and Gordon's a Go developer, and they can all use it for different purposes. Now, without Bazel, what Jared would have had to do is tell Patty about this tool, cool tool, and then build an executable for her and maybe email it to her. And she's excited, and she shares it around, and people ask him about it. So he puts it in a shared folder, and then people can get it from there. And they use it, and it's popular, and they copy it to different places. And now Jared has some requests to make changes. So he makes changes, and he makes another version. But then there's all these versions like traversed across the company. And now there's different versions, and people say there's some issues. And then he figures out it's this old version. So now he has multiple versions he's kind of supporting. And they want to make changes, and they don't know exactly how because they're not Java developers, and it's hard for them. They don't even have the build tools to do that. And now he ends up kind of, part of his job is to support this tool that he doesn't really want to be in like a big role of support for. And with Bazel, you don't have to compile it. You just tell people how to build it, and they build it themselves. They don't need the tooling to be installed and stuff like that. You don't need to manage executables. So it's much, much more easy to share tooling across the company. So Bazel makes tool sharing easy. Now, let's talk about this other scenario where Becky and Fred are at the same company but at different teams. All right, and Fred's team has been doing some awesome work, and they built these cool libraries, and Becky just found one of them, and she wants to use them. And it's basically, it saved her like a week of work, and she's really happy about it. And she starts using it, and maybe she tells Fred, maybe she forgot, maybe she's not sure she should. And now Fred is going to change that code. Maybe he even has a branch waiting to be merged to change that code. And he breaks Becky's code. And he breaks it at a time where it's not convenient for her. Maybe she's going to release now. She needs to update the dependency. And it's not a convenient time. And what you have with Bazel is that you have the visibility attribute for folders and for targets. And that way you can actually control who can use which code. And different teams can say, all right, this folder, this is our folder, this is our team's folder, and you can't use it unless you explicitly ask for permission. And that is a conversation you want to be having, because that's a point in time where you can talk about what it means to use that code and how we collaborate on that code. And what about ownership? What about changes to that code? What about the time span of how long that code is going to be living, and the release process and timing for that releasing that code? So Bazel helps sharing code across the company easier. And what many companies do to solve this is actually silo up different teams, and different teams are working on different repositories, so you don't have that kind of dependencies that might break things. But then you can't share code as easily, right? The next example I want to show you is about Patty, who just wants to make a small change in a web app, and she's a Python developer. Now, Jess, who is a JS developer, he's like, yeah, sure, like he's optimistic. Like, Patty, what experience do you have with web development? And she's, yeah, I built this HTML website for my parents once in high school. And he's optimistic, and he's like, all right, so you can go ahead, just install Gulp and CSS and NPM and Goglify and NG and Webpack, and you're ready to go. And yeah, you can see that this generates some friction for Patty in making these small changes. So Bazel actually lowers barriers between teams in a way that if you want to make a change in another team's code that is not in your like proficiency language, you can do that, and you don't have to wait for them to actually do that on their cycles. You can do that on your cycles, and if it's important to you, you can prioritize it. And that lowers the barriers for cooperation and removes friction between teams across platforms and languages. So some key points I want you to take from this deck is think about how you, in your team, in your company, encode knowledge, okay, in your code. And how easy is it for others to understand and use it? Think about how others can build, test, and run code across teams, how they can use the API that other teams are opening up, and how easy is it to share code and tools across the company. Now, if you have questions, you can ask me, of course. And there's also, I have a little bit more time, so we'll keep questions to the end. I have something else I want to talk about. You can look at this repo called the Startup OS, which is a template for a repository for a company, which is what your repository for your company could look like using Bazel, gRPC, and protocol buffers. And it has several best practices on how to use these technologies, as well as some others. And also, if for startups, there's this Cloud Credits program. You're welcome to sign up. And now I want to talk about, I have this kind of mini lightning talk inside of this talk. Okay, so I want to talk about a code review tool that's related to Google's technologies and makes it easier to use Google's technologies. But not only Google's technologies. It's called Reviewer, and it's a multi-repository code review. So why is it important? Why do you need a code review tool, especially a multi-repo code review tool? So you think about proto files. Where do you put these proto files? We've had a lightning talk yesterday about how managing proto files across dependencies is challenging, and how you have the multi-repo and monorepo workflows and how that is different, and dependency hell, which is, it can make dents in your flow and actually break you in production. So how can you make all of these easier? So this tool can help you. So basically, it's a code review tool, and it's multi-repo. So this basically, it looks like a standard code review tool. It's built, it's inspired by Google's internal code review tool. And these are just pictures of what it looks like. OK, just a standard tool. Now, what is interesting about it? It's multi-repo. Multi-repo means that you can actually have one PR that makes changes across multiple repos, okay? And these PRs, this tool can actually do atomic commits across these repos. And it is hosting agnostic, which means that you can actually work with repositories hosted on GitHub, GitLab, on-prem, Bitbucket, Google Cloud repositories, and others. And currently, it's supporting Git, but it's built to be extensible to Mercurial and Piper and others. And it supports private repos in an interesting way where you can actually have like 2 repos, right? It's multi-repositories. You can have 2 repos, one private and one public. And the private repo, when you do code review, when you look at the tool, you see changes from both repos. And you can collaborate on your public repo, which is open source, with someone outside your company, and they can only see the public code and not your private code, and it's secure in that way, and I'll talk about why it's secure in that way. And you can view local changes without pushing the code to GitHub or to whatever host provider. Now, how it does all that is this is the architecture. So you have the Angular app in the middle there. And it gets the metadata from Firestore. And it actually gets the files, the code, and the diff from a locally running server. So no code actually gets off of your machine at any given time, which is why you can actually work with private and public repos and stay secure. And then it gets the data from Git. And that's why basically it basically works with the Git protocol. That's why it can work with various hosting providers. And that's basically like the architecture. Yeah, and that's it. I see the star is removed from where it should be. But that should mean that you can start the repo. Yeah, so that's it. Happy to take any questions.